Addition and subtraction has a different set of rules than multiplication and division. When we add and subtract, the rule is going to be to count place instead of significant figures, and the answer is going to have the same place as the number with the least place. Place like ones, tens, hundreds, or tenths, hundredths, and thousandths. I think I can pretty easily convince you of the addition-subtraction rule. The multiplication-division rule, people won't buy into it unless I actually make them use all three different kinds of rulers and they look and they see what happens to all those different answers. With add-subtract, I think I can sell this to you based on some myths that were told to you by your elementary math teacher. Once upon a time, you learned to add numbers with decimal points in them. And what your teacher told you to do was take the numbers, put them in a stack so that the decimal points lined up, drop the decimal down, and start adding. What did your teacher say went in this blank right here? 310.7, what did they tell you went there? 0. Because then you could add it up. It'd be like 0 plus 2 plus 0, that gives me 2. 7 plus 4 plus, they said I could put a 0 there too, so I guess 0. So 7 plus 4 plus 0, that's 11. Carry the 1. 1 plus 0 plus 4 plus 7, 12. Carry the 1. 1 plus 1 plus 2 plus 8. I should be able to do that. 1 plus 1 plus 2 plus 8, more 12. Carry the 1. 1 plus 3 plus 1, 5. Assuming I didn't do any really bad addition there, your math teacher would have told you that is 522.12. Okay, now let's really be honest about what's going on. This is 310.7-ish. What's actually here? Yeah, we don't know. Like the 7 was a guess, and so anything after the 7 is really a big guess. And this is 24.42-ish. And this is 187-ish, which means I don't know this number. And I way really don't know this number because it's like beyond 7-ish, I really don't know. And beyond I really don't know is I haven't got the foggiest idea. Okay, so let's redo the addition. I don't know plus 2-ish plus I really have absolutely no idea whatsoever. What is the answer to that? I don't know. Like for the first time in your life, the correct answer to the teacher's question is, I don't know. No idea what actually goes there. Okay, next column. 7-ish plus exactly 4 plus I don't know. 11 plus some extra of I haven't the foggiest idea of how much extra. Okay, I think we got to go with maybe we don't know that either. Okay, but we knew we had at least 11, so the 1 got carried. So definitely 1 plus definitely 0 plus definitely 4 plus 7-ish. Yeah, I think 12-ish is probably reasonable. So this is kind of ish right here. But hey, at least we're kind of getting in the ballpark now. Okay, tens place. If this was 12-ish, we still got to carry the 1. So definitely 1 plus definitely 1, plus definitely 2, plus definitely 8. Oh, hallelujah. How much is it? 12. And it's actually 12, and this is not a lie anymore. And then we carry the 1, and definitely 1 plus definitely 3 plus definitely 1 is definitely 5. The way I see it, we know the 5, we know the 2, and that's actually the sum total of everything we know here. I am allowed one estimated digit, so I'm going to allow myself 2-ish. And I think that contrary to what you were told in elementary school math, the answer to this is actually 522. Eric.
Can you just add them all right away and just take away the decimals or whatever?
Yes. I am going to most certainly propose that we do not take every set of numbers we need to add and subtract, stack them up, and go through this ridiculous exercise. I'm going to propose that instead we use our calculator, because we really can figure out where we need to round this. This one went to the tenths place, the hundredths place, and the ones place. The rule says keep place equal to the least amount of place. So the rule says stop in the ones place because that matches our one that has the least amount of place. So this is my cell for why the add subtract rule has to be what it is. In actual practicality, if I need to subtract these numbers, here's what I'm going to do. I'm going to use my calculator. 4.782 minus 3.41. My calculator says 1.372. And now I'm going to look at the place situation. This one goes to the thousandths. This one right here goes to the hundredths. So that means I can only go that far. To the hundredths place. So the answer to this is 1.37. Okay. We are not going to have to stack up the numbers every time we want to do this. We can just calculate and then round off. Now, don't throw the numbers out before you calculate. Like, don't just chop this one off here before you do the addition or the subtraction. Subtract and then do your rounding. The problem with adding and subtracting is that this idea of place becomes grossly distorted by scientific notation. If this is times 10 to the third, and this is times 10 to the second, the first decimal place is actually a different place in each of those numbers. Unfortunately for adding and subtracting, when we operate in scientific notation, we have to have a different rule. That different rule says, use your calculator to find the answer, and then rewrite the problem to have all the numbers with the same exponent as the answer. Now, you do not have to fix it for your calculator. Your calculator can manage this, no problem at all. So let's start by dumping it all into our calculator. 6.41 times 10 to the third minus 7.8 times 10 to the second. I'm going to put it in scientific notation just so we can kind of get at what we're trying to get at here. My calculator says 5.63 times 10 to the third. Now that I know that the answer is times 10 to the third, I'm going to go along this entire problem and write everything as times 10 to the third. Well, this one's already done. 6.41 times 10 to the third. But 7.8 is written in the form of times 10 to the second. The secret to doing this is lip. Left is positive. I would like to add 1 to this exponent because 2 plus 1 will be 3. If I want to add 1 to the exponent, I have to move the decimal to the left. Left is positive. 0.78 times 10 to the third equals 5.63 times 10 to the third. Once I rewrite everything to the third power, I realize that this one goes to 2 decimal places, this one goes to 2 decimal places, and therefore I can keep that one to 2 decimal places. If I wouldn't have rewritten this, I would have accidentally rounded off to 1 decimal place. But that 1 decimal place to the second power is actually the second decimal place when you're to the third power. These powers have to match before you can make the comparison. The last idea is, what if things get together? Like, add and subtract and multiply and divide don't always stay separate from one another. If you have a mixed family operation, you're going to do standard order of operations and just be sure to round before you switch families. So looking at this one right here, within the parentheses, I'm going to multiply. Multiplying, I count significant figures. 2, 3. I've got 4 significant figures here, and I've got 2 significant figures here. So that means I've still got this 26.38 minus whatever I get out of this parentheses. So 7.215 times 0.47 3.39105. 4 sig figs, 2 sig figs. I got to round that thing to 2 significant figures. That's going to round to 3.4. Because that has 2 significant figures. Next, I have to subtract. When subtracting, I look at place. This one goes to the hundredths. This one to the tenths. So now I have to clear my calculator and do this again. 27.38 minus 3.4. And I'm only going to be able to keep to the tenths place here because tenths is the least amount of place. Okay, so we have 22.98. I get to keep to the tenths place. The 8 says round the 9 up to 10, making the final answer here 23.0, because now this follows the add subtract rule, and goes to the 10th place.